based on some evidence. I mean, yeah, I mean, it is true. If it's contrary to previous belief, and the previous belief was Aristotle, then that maybe not is okay to do. But if it's contrary to previous belief that was established by a series of studies and research over a period of time, and the contrary one is likely to be the one that's the statistical outlier again. Now, there could be circumstance where the new report, there's no reason right off the bat that just because it's the latest report means it's more reliable than the one that came out last year or the year before that. Unless, of course, the latest one has some particular reason why you should think that, like they just bought a fancy new instrument with higher resolution and everything and could see something nobody else previously could see. Yeah, in that case, maybe it is true. But generally speaking, all other things being equal, that's not the case. So that's what I call a recipe for wrong science. And now, recipe for wrong science news, coincidentally, happens to be the same three things. Because these things that statistics, just by the way they work and the way the publication system works, mean these things likely to be wrong. These are precisely the things that science journalists are the most likely things to write about. Because what do you want to do if you're a journalist? You want to write about the first time somebody reports something, the first time they just claim to discover this or whatever. The important study is the next one or the next one. They confirmed it. You don't care about that. It was already reported. So you write stories about the first time somebody found something. Now, if it's in a hot research field, that's where you go, oh, people want to know anything that's going on in those hot fields, so we write every little study that comes up in those hot fields. And if you want to really get the journalists going, contrary to previous belief, thousands of years of investigation have been overturned by a new study, published in the Lancet. But I try to illustrate this I've shown this to my readers. If there's 100 drugs people are testing and one of them works, 5 of them are going to look like they work by chance. The first report is likely to be one of the others and not the real one. And again, the hot research field. If you have a small number of labs working on a question, then a 1 in 20, a 0.05 report is going to hit one of them. If you have 1,000, it's going to be way more. Okay, so, but is this really right? I mean, people say, I tell people this stuff, and they say, oh, you're exaggerating. Or, how do you really know? You just, this. And so I watch for the occasional thing that comes along that kind of illustrates my point concretely and dramatically. So I'm going to show a few examples of that. This was a study on acute coronary syndrome, a diagnosis that is not terribly uncommon. And these guys went back and looked over many years of the literature and found all the studies that had associated any genetic variant with this syndrome. And they found something like 70. I think I've got the number here. Probably. So I think they found 85 variants in 70 genes is what they found that were associated by studies at a statistically significant level with this syndrome. So they got this bright idea. Let's go look at a bunch of people with the syndrome and then compare it to controls who don't have the syndrome and see if how many of those genes actually are more common in the people with the syndrome. So, you would expect if these genes actually are associated with the syndrome, you'd find them more in the people with the syndrome. So they found 85 variants. Found 85 variants in 70 genes. They got their control group, and they analyzed it, and they found none of them. They found one that looked like it was more in the group, but that would be expected by chance. So their conclusion was that you can actually no evidence that any of these genes, these 70 genes, 85 variants and 70 genes, that papers had been written doing the analysis, finding a statistically significant association of that gene with that syndrome. And if you look in the people with the syndrome, none of them were more often shown up in people with the syndrome. Now, this is why you know, when you do stories in your journalists and you get criticized because you say, oh, you wrote last week that this was bad, now this is good, this is bad, this is good. We're just writing what the studies say, but this is why that happens, is because they keep changing because most of them are wrong. Okay, this is, more genetic stuff. I'll just go quickly. This is getting better because now, and I should say, I need to emphasize this.
Do you mean wrong, or they observed a statistical anomaly? Or
well, they concluded.
Do you mean actually wrong as in?
Well, I mean wrong, and they concluded that something was associated with something that wasn't. Okay. They write that. That's what's. I should say, statisticians all over everywhere have developed a great many really sophisticated tools for trying to help cope with some of these problems. And a lot of these issues